या ऊपर करना नीचे।
Hi students, so welcome to this new video, and today I'm going to do circle revision class. So many people must be like, how come on online right now, because I know this Sunday we have exams on circle, so people have lots of doubt, and so on the people's demand this revision class is planned. And in today's session I will go to revise all the 19 properties of the circles, as well as some people can ask the doubts and the difficulties. So in case student you have doubts or difficulties, don't hesitate, immediately put in the comment box, so that immediately those doubts I will take on the priority basis. And in case if there are no doubts, then I'll keep going ahead with the properties. So students are waiting for your comments, and then accordingly I'll take the calls what should be done. And a most important instruction, student, keep reading your notebook and the geometric compass box and all that stuff, so that if in case it will be handy, the session will go very smoothly. And students, whenever I'll be explaining, keep watching what's going on the board, and then I'll give you time to write it down, the notes and all. So keep your notebook and writing material stuff ready. I'm waiting for your comments. 1 minute. Yes, so someone has written already, so please revise first of all the tangent properties. So first of all I'll do the tangent properties. So student, what are the tangent properties? So first of all understand what is a tangent. So in case if we have these as a circle, and if we draw any line, so if any line touches this circle exactly in one point, then this line is called as tangent. I hope student this is very clear to you. In case if we have a circle and if there is a line which touches the circle exactly in one point, then that line is called as tangent. And in total we have 6 tangent properties. So student, just make a note quickly. A circle, draw one line which touches the circle exactly one point, and that is called as tangent. So I'll erase this part and we will write it down quickly. The 6 tangent properties. What are the 6 tangent properties? First one, the radius and tangents are always perpendicular. This is basically radius. Now what is radius? A line segment joining center to the circumference is called as radius. Janam Ranavat, is it in the batch? I mean, Jailam Ranavit is not there. So anyway, what is radius? So radius is a line segment joining center to the circumference. It's called as radius. And what is a tangent? A line which touches the circle exactly in one point is called as tangent. And if there is a radius and the circle and the tangent have one common point, then that is called as point of contact. So radius and tangents are always perpendicular at point of contact. So what is the first property? Radius is perpendicular to tangent. Number 2. Say from exterior point to this given circle, only two tangents can be drawn, and that too they are equal. From this exterior point, how many tangents can be drawn? Only two tangents can be drawn, and that too they are congruent. So that is the second property. Two congruent tangents can be drawn from exterior point. So this is point P exterior, and PA and PB are the two tangents, and that too they are congruent. So students, understand over here something little detail in this property. This is radius in tangent, which is 90 degree. This is radius in tangents. Again, it is perpendicular. So this is 90 degree and this is 90 degree. Obviously, these are radii, so they need to be congruent. And in case if you join over here, say in case if you join this OP, so please understand, students, these are not properties but basic things or basic congruency things, like these two triangles become congruent. Basically, these two are congruent because right angle, hypotenuse, and side. So by RHS test, these two triangles are congruent. So this side will become congruent to this side AP will become congruent to side BP. Why? By CPCDC. If these two triangles are congruent, then the corresponding sides are obviously congruent. Now, two more things. This angle is always equal to this angle. So angle APO is always equals to angle BPO. I hope you are getting this, student. Angle APO is equal to angle BPO. Why? By CPCTC. Even this angle supposed to be equals to this angle, again by CPCTC. And third thing which is supposed to be like important, if these two are 90 degrees, then even these two will be adding up to 180 degrees. So quadrilateral AOBP is supposed to be cyclic quadrilateral. Although students, in case if you have not understood something, don't worry. You can put it in that comment box and I will repeat that particular part. So by now we have completed two properties. One thing is radius and tangents are always perpendicular. That's number one. And number two, only two tangents can be drawn from that exterior point, and that too they are congruent. Only two congruent tangents can be drawn from exterior point. I hope these two properties you have already made a note. In case not, please do it. So what is the next thing? Say when the chords are intersecting internally, when the chords are, say these are the two chords AB and these are two chords CD, they intersect internally at point P. So when I know these are not tangents, but these six properties come into under the topic tangent properties in your textbook. So I am just explaining all the six properties related to these tangent properties. So these are basically called as PA into PB is equal to PC into PD. So what is the third property? PA into PB, PA into PB is equals to PC into PD, PC into PD. So always student remember that, come to that center or come to that point of intersection and then go from one corner to the corner of that particular chord. So PA into PB is equal to PC into PD. And what is the next thing is, if these two chords are intersecting externally, so they are intersecting now at point P, and this is chord A and B, and this is chord C and D. So again the property remains the same. PA into PB is equals to PC into PD. See students, what you have to remember again, wherever the two chords are intersecting, go to that point first of all. Let's say point P, and then P into A, I mean PA into PB is equal to PC into PD. Many students write this property other way around. AB into AP is equal to CP into DP, which is absolutely wrong, and your answer will go wrong. And you think, oh sir, we have done everything right, and then why our answers are wrong? Then obviously it is because you're writing the property wrong. It is supposed to be PA into PB is equal to PC into PD. So whenever you draw the diagram, see to it that point of contact is what, and then from there 4 points, PA, PB is equal to PC into PD. I hope students you are understanding. So make the next 2 parts. So by now we've learned 4 properties, 2 more to go. So I'll just take 1 minute break because people might be writing this. So anyway student, we'll go to the next 5 and 6. So I am clearing again this. So probably people who have recently joined, for them, recap a little bit. We are right now doing tangent properties. First property what we learned, radius and tangents are always perpendicular. Second one, two congruent tangents can be drawn from one exterior point. Third one, PA into PB is equal to PC into PD when they are intersecting. When the two chords are intersecting internally, PA into PB is equal to PC into PD when the two chords are intersecting externally. What is this fifth and sixth? See, this is called as tangent secant property. What is tangent and secant property? Tangent and secant property. So what is this tangent and secant property? There would be one tangent and there would be one secant. So this is the tangent because it is touching the circle exactly in 1 point. Let's say this is T and P, and this is like secant A and B. So we've got one secant and we've got one tangent. So it is called as tangent secant property. So what does this property say? PT square, that is tangent square, is equal to PA into PB is equals to PA into PB. Many people even this property they misunderstand. They write PT square is equals to AB into AP, which is absolutely wrong. Reason, we have to go to the point of contact. As I already told over here as well as here, you have to go first of all to the point of contact. From there, PT square is equal to PA into PB. PA into PB. I hope you have understood, student, this. And then, so I'll write it on this. PT square is equals to PA into PB. And now what is this last tangent property is like the most important property. So keep watching this video. I'll just shortly write it down. What is the sixth property? This is most important because definitely 1 mark question has to be there in your board paper. So that is something called as angles in alternate segments are always equal. So I'll write it down that property. Should I clear this? In case if you have not written down, then please write it on this. PT square is equal to PA into PB. So, what is this tangent secant property? In case if you are finished, we'll go to the next property. What is the sixth property? Is angles in alternate segment. Angles in alternate segment are equal. I'll repeat, angles in alternate segments are always equal. That is property number 6. Angles in alternate segments are always equal. So these two words are very, very important. What is alternate segments? So what is this angles in alternate segment, student? See, it's very simple. Angles in alternate segment means there are two angles. One is in minor segment and another is in major segment. So where is the minor segment and where is the major segment? Let's check it out. Say suppose we have this circle and this is one tangent given. See, listen very carefully. This is very important property. We have one circle and we have got one tangent, and also we have one chord over here. Okay, so whenever we have these three things in common, definitely one mark will be on angles in alternate segment. So where exactly the angles in alternate segment is forming? See, student, look at this. Okay, now some people might be confused, so I'll draw something like this. See, this is called as minor segment. Why this is called as minor segment? Because let's say suppose this is a center. So where center does not exist, it's called as minor segment, and this is called as major segment. Again, what is minor segment and major segment? Alternate segment means one angle is in minor segment and other angle is in major segment. So we have one angle in minor segment, isn't it? So this angle is in minor segment, and now there would be one angle formed in the major segment anywhere. See, we have major segment so big like this, isn't it? So anywhere this angle can form. So this angle would be always equal to this angle. I get it? That means if this is 30 degree, even this is going to be 30 degree. If this is 130 degree, even this is going to be 130 degree. That is called as angles in alternate segments are always equal. I hope students you have understood. In case if you have doubt, don't worry, you can put it in the comment box. In case if you have liked this, please like it and share it with your friends. And by now, in case if you have not subscribed this Easy ICC channel, subscribe it right now only and press that bell icon so that you will always get the notification whenever we come for online classes. Oh, so Jainab Ranavat is here. So what is radius? I had already taken over here. Radius is perpendicular to tangent. So Jainab, are you getting what is radius is? Yeah, sure. So someone is saying, so please explain these angles in alternate segments are equal. Explain once again, no problem. I'll redraw the diagram so that you can understand it. See, understand very carefully. Say, suppose if we have a circle, and now three things we need. One is circle, one is tangent, and we need one chord. So because of this chord and the tangent and the circle, we've got one minor segment. So angle is forming over here in the minor segment. So anywhere if the angle forms, so let's say anywhere even over here on this side. So these angle and these angles are always equal. This is called as angle in minor segment. Angle in minor segment. And this is called as an angle in major segment. Angle in major segment. So angles in alternate segments are always equal. So in case if you have still not understood, you can ask me again, sir, please explain what is this minor segment and major segment. I can do that. So right now we have finished all the 6 tangent properties. So some students are asking, so please do some sums based on tangent properties. No worries, we'll do right now 4 to 5 sums based on tangent properties. Yes, someone is asking, sir, can you give the proof for this? Surely I can give this proof for this. It's really simple. Say suppose we have these angles, say let's say 30 degree. So what will be, even these will go to be 30 degree. And now why that angle will go to be 30 degree? We have to prove this by similarity. Actually, we will not learn this similarity. So once we finish the similarity chapter, I'll explain it quickly in the class. So right now this is like a revision class and people just want number of sums. So we'll go quickly ahead with that revisions class sums, and then in the class tomorrow probably I'll explain to you what is this proof and all. So right now we'll go with number of sums. Say suppose I have already WhatsApp this worksheet on your WhatsApp group. So please check out your WhatsApp group. I am solving right now sum number 9, which is based on angles on alternate segments. So once you understand how to use this property, the proof is very simple. It's just in 4 lines. I can explain to you quickly. Let's solve first of all few sums, and then we'll come back to the proof in case if you have time, surely. So say suppose we have this circle and say we have this as a tangent. Okay, say AB is a diameter. I am solving sum number 9, the worksheet which I have already WhatsApp to you. Please check the WhatsApp for the worksheet. Say we have this diameter AB. AB is a diameter and it is meeting at Q. So CQ is basically the tangent. If angle CAB is 34 degree, where is CAB? CAB is 34 over here. What you have to do? Calculate angle CBA. You have to find this angle CBA, and second thing is angle CQA. Angle CQA. You have to find this. These are the two things. What is to find? To find. You have to find angle CBA and 2, you have to find CQA. So what is the CBA? It's very simple. Students, see, look at this. If AB is a diameter, if AB is a diameter, we have one property. What is the property? Angle subtended by a semicircle is always a right angle. Angle subtended by a semicircle is always a right angle. So we know that this is 34 degree, this is 90 degree, so we can calculate this angle CBA. So first statement you will write angle ACB is equals to 90 degree, and then you write it down the reason. Angle subtended by semicircle is equals to 90 degree. 2. Now in triangle ABC, 34 degree plus 90 degree plus angle CBA is equals to 180 degree. Why? SAT property. What is the SAT property? Sum of all angles of the triangle is always equals to 180 degree. What is SAT property? Sum of all angles of the triangle is always 180 degree. So angle CBA is equals to 180 degree minus 34 minus 90. So 90 minus 30, 60 and 56 degrees. And that's your first answer. This we got as 56. And now how are we going to calculate this second part? Over here we're going to use today angles in alternate segment. Now how do we use angles in alternate segment? Check it out. So student, look at this. If this is 34 degree, then even this angle going to be 34 degree. Why? Because this is angle in major segment. Look at this. This is the chord. Could you see? This is the chord. This is the tangent, and this is like the minors angle in minor segment. It's supposed to be equals to angle in major segment. So angle in minor segment is equals to angle in major segment, because angles in alternate segments are always equal. So if this is 34, even this is going to be 34. So let's start writing these. So we're going to write angle BAC. Angle BAC is equals to angle BAC is equal to angle BCQ. Equal to angle BCQ. Why? Because what is the reason behind this? Why this is 34? Because angles in alternate segments are congruent. Angles in alternate segments are congruent. And once you got these as 34 degree, let's say 34 plus this part 2 is supposed to be 56 degree. Isn't it simple? Exterior angle of the triangle is always equals to sum of its remote interior angle, isn't it? So 34 plus angle CQB is equals to 56 degrees. What is the reason for this? Exterior angles of the triangle is equals to sum of its remote interior angle. So angle CQB is equals to 56 minus 34, which is 22 degrees. So this is like final answer. Put the boxes for all final answers. This is how we have completed one very simple sum based on tangent properties, or angles on angles in alternate segments are always equal or congruent. I hope you have understood, student. In case not, please put it in the comment. Yeah, many people are saying, sir, do this sum number 5. I'll start it. In case if you have completed, I'll clear this board. So student, what is this sum number 5? In the figure, AB is parallel to CD. In the circle, AB is parallel to CD. So this is AB, CD, and this is point A. And we know that angle BC is 80 degree. This is 80 degree. So student, this diagram is not up to the scale or not with the scale. It is just imagination. Angle BAC is 25 degree. Angle BAC is 25 degrees. Angle BAC is 25 degree. What we have to find? We have to find 3 things. 1, 2, and 3. But the first thing is angle CAD. But the second thing is angle CBD. And what is the third thing is angle ADC. So let's check out where is angle CAD. CAD. So this part of the sum. It's really simple, student. How are we going to find this x? Let's say this is x. So how are you going to find this x? See, 80 is supposed to be this 25 plus x. Isn't it? Why? Exterior angle of the cyclic quadrilateral is always equals to its interior opposite angle. So if this is 80, 25 plus x supposed to be 80. So x is equals to So x is equals to 80 minus 25. So student, how will you find this x? That is very simple. 80 is equals to 80. Okay, so I'll write it as a statement. Angle BCE is supposed to be equals to angle BAD. Angle BAD. Why? Yes, can someone guess it? Exterior angle of cyclic quadrilateral is equals to its interior opposite angle. So angle BAD is supposed to be 80 degrees, isn't it? Because BCE is 80, so we substitute 80. And now what is BAD is made up of? BAD is made up of this 25 plus angle CAD. See, angle BAD is made up of BAC, this portion, plus CAD, this portion, isn't it? So 25 plus x. So 25 plus CAD is supposed to be 80. So angle CAD is equal to 80 minus 25. So 80 minus 20, 60 minus 5, 55 degrees. So that is this answer. 55 degrees. So we got this angle as 55. So first part is that. So your 1 mark is confirmed. Always remember that there are 2 properties confirmed. I mean, surely ask in your board paper. 1, the cyclic quadrilateral properties, and 2, angles in alternate segments are always equal. Okay students, so how will you find angle CBD? Angle CBD. So again we will just join this. So over here angle CBD is forming. So if this is 55 degree, even this is going to be 55 degree. Why? Angles subtended by the same arc at the circumference are always equal. So I'll just clear this part of the board. So angle CBD is equals to angle CAD. Angles subtended by same arc are always congruent. So what is angle CBD? CBD will going to be CAD, that is 55 degrees. So even this is 55 degrees. And what is angle ADC? ADC, this total angle. That's very simple. How you find this angle, this full angle? See, look at this. These 2 lines are parallel. If these 2 lines are parallel, and we know that this, okay, I'll just clear this part of the board. If these 2 lines are parallel, and if we know this is angle 80 degree, how are we going to find this? If the 2 lines are parallel, co-interior angles are always supplementary. So let's say this is 80 plus z, it is going to add up to 180 degree, because when these two lines are parallel, co-interior angles are supplementary. So angle ADC plus angle DAB is supposed to be 180 degree. Why? Co-interior. What is this co-interior angle, student? Co-interior angle which are between the two parallel lines and on the same side of transversal. So co-interior angles add to 180 degree. So angle ADC is equals to 180 minus 80, which is 100 degrees. So this was 100 degrees. I hope these three answers you have got, and that too all are right. Please put this quickly in your book. Okay. Now we do sum number 8. Sum number 8. So student, in case if you have doubt from your textbook, even you can ask that page number and sum number. Don't be just dependent on this worksheet, because this worksheet has very limited number of the sums, and this worksheet has been posted to you because we should have some aim to accomplish or to do. That is the reason. So in case if you have any doubt from your textbook, from other exercises, you can still ask me that as a doubt in your comment box. So meanwhile, I'll try and solve this sum number 8 because it's again based on tangent properties. So in the figure given below, PT touches the circle. So there is this circle given, and then there is this tangent given, and then there is something like this, or the secant is given, and this is Q, and this touches at this point at R, and there is this point is S, and this central point is O, and O is the center of circle. This is very important information. O is the center of the circle. This is T out here, and this is point P. And now what exactly is asked? Let's read this sum once again. In the given figure, PT touches the circle at O, with center O at R. So this PT is touching the circle with center O at R. So this PT touches the circle with center O at R. Diameter SQ. So this SQ is a diameter. If SQ is a diameter, students will understand whenever SQ is a diameter, we can draw this dotted line SR, and this makes 90 degree. This is like you must understand, this is like a hidden information. If SQ is a diameter, angle SRQ is right angle. This is hidden information. When produces PT at P, if you produce PT at P, so it is given like that with it as information, and angle SPR is X. Angle SPR is X degrees. Angle QRP is Y. Angle QRP, this portion. Can you get this? This angle in minor segment basically, because this is a tangent, this is a chord, and this is a circle. So this is called as minor segment. Show that x plus 2y. So what were to prove that? To prove that. What were to prove that? X plus 2y is equals to 90 degree. This is what we're to prove. Student, this is very simple sum. This is too easy sum. And basically, many people can't solve this type of sums because these are kind of prove that sums. And in prove that sums, what exactly happen? Like students do not know how to solve it, because this is not that like finding these angle kind of question. So in prove that sum, what we do, first of all we take LHS or RHS, and then we start at LHS and we end up with RHS. It is that easy. So before starting with the LHS, let's think about the diagram. In the diagram, it is given that this is y degree and this is x degree, and more information given that SQ is a diameter. And as I already told you, SRQ going to be 90 degree because SQ is a diameter, and the angle subtended by the semicircle is always 90 degree. So if this is angle y, what will going to be this? This angle. Obviously, this is y, then even this will be y. And I have just now explained in previous sums or in the while explaining the property, angles in alternate segments are always equal. Angles in alternate segments are always equal. So if this is y, even this is going to be y. And student, if this is 90 degree, this is y, this will going to be, can you guess what is going to be? This will going to be obviously x, you can say, or else if this is 90 degree, this is y, and this will be 90 minus y. So you can say this is 90 minus y. And what is the exterior angle property say? 90 minus y is equals to x plus y. What is the exterior angle of the property say? 90 minus y. 90 minus y is supposed to be x plus y. Over here in triangle PRQ, if you produce this, this is exterior angle. And what is this exterior angle says? Exterior angle is equals to sum of its remote interior angle. Exterior angle is always equal to sum of its remote interior angle. So we got 90 is equals to x plus 2y. Hence proved. In 2 lines of the over. In 2 lines we have completed this entire sum. But student, you can't do this in the examination because we will have to always write what is this y. So this is y because angles in a semicircle, angles in alternate segments are always equal. Then if this is y, this is 90 degree. Y, angle subtended to the semicircle is 90 degree. And then if this is 90, this is y, then this is going to be 90 minus y by SAT property. And then this angle is always equal to sum of its remote interior angles. It's that easy. And I have just written the final steps. So students, you will have to write it down in your book, everything. I hope you have understood this sum. Yeah, someone had finally asked, they are saying clarity is affecting. Okay, so the last step is very simple. This is y because angles in alternate segment. This is 90 degree because angle subtended by the semicircle is 90 degree. If this is y and this is 90, this will go to be 90 minus y because SAT property. And if this is 90 minus y, then this plus this is supposed to be. Yes, someone had asked, can we do by triangle property? You can do by any property. In ICSE board, you can write your steps in the way it strikes in your brain. Just make sure that whatever statement you write the proper statement reasons. So if your statements and reasons are matching, you can write anyhow your proof and all the proofs are accepted. So, okay, so last step is this again, 90 minus y. What is this 90 minus y? This is exterior angle, and exterior angle is always equals to this plus this. So x plus y is equals to 90 minus y. So x plus y is equal to 90 minus y. So this y goes to other side and becomes 2y. This y we shift to other side. So page number 427. So someone has asked page number 427, sum number 13, part A. This is very simple sum, student. Please open your textbook, page number 427 and sum number 13A. So it is given that this is like a semicircular things. It's a semicircular shape, and there are these three semicircles. Oops. I'll redraw. There are three semicircles like this, and like this, and then there is one more circle like this way, touching all these three circles, and it is given that AB is 8 centimeter. This is AB, which is 8 centimeter, and M is a midpoint. M is a midpoint of AB. This and these two are equal, and there is point C over here. So what we are going to do? Find the radius of the small circle. So we're going to find the radius of the small circle. That's the question. So students, I remember this sum very well. While doing this class, I had taught the shortcut way of doing the answer also. So remember students, what is the shortcut for this sum? The shortcut is the radius of the circle, radius of circle. Jalam, can you tell me what is the radius of the circle? No, what is the radius of the circle? Jalam Ranawat. Jalam, you can type the answer. Radius of the circle. What is the radius of the circle? So anyway, radius of the circle is going to be 1/6 of base diameter. 1/6 of AB, which is 1/6 of 8, which is 4/3 centimeter. This is just a shortcut. So the student who are generally appearing for some competitive examinations, or some kind of any competitive examinations, in such kind of sum comes, you can do this method. But in the boards, you can't use this method. Anyway, for that, in the boards, what to do and how exactly this type of sums can be solved in the examinations, I'll help you right now. So keep watching this video till I'll come back 1 minute break. So student, have you figured it out how you will find it? It's really simple. This sum is generally, I have explained 2 times in your classes. 1 when I taught you area and perimeter of the circle, and 2 when I taught you the chapter circle. So both the time I have explained you this sum, and by now I hope most of you all know, but still if someone is asking, I'll explain to you quickly. Look at this students. What I'll do subsequently, I'll just draw this perpendicular. Okay, this is basically radius of the biggest semicircle. See, understand this figure first of all, student. There are 3 semicircles. One is this outer with a diameter AB. Let's say there is point N. So there is another semicircle with AM as a diameter, and there is one more semicircle with MB as a diameter, and then there is one circle with O as a center, or with C as a center, with C as a center. And what we have to find, is, let's say, OC, or we have to find the radius of that particular circle. And the radius of that particular circle we have assumed, let's say it's R. So let RV the radius of circle. So we understood this is R. Obviously this will also going to be, if this is R. What is OM? Please write it down, student, all of you. Write it down this in your notebooks immediately. What is this OM? OM is supposed to be the radius of this biggest semicircle. And the diameter is 8, so the radius will going to be 4. So OM will going to be 4 centimeter. 8 upon 2. Once you got OM is 4, and if OC is R, what will be CM? CM will going to be, please understand, this is 4, this is R, so this CM will going to be, if this is 4, this is R, so this is going to be 4 minus R. 4 minus R centimeter. Once you got this CM, okay, let's understand there is one more point. Let's say P. P is the center of this. So what is PM? PM will go to be, if this is 4, then P is the midpoint. So what is PM? 2 centimeter. And what is this PC? What is this PC is? PC is going to be, this is R and this is 2. So this is 2 plus R. 2 plus R centimeter. Understand this, student? This is very, very crucial. This is 2 centimeter because the radius of this. So this is 2 and this is 2 and this is R. So this is 2 plus R. 2 plus R centimeter. This is 2 centimeter and this is CM. So CM is 4 minus R. And now, student, you must know that, see, this is a small semicircle and this is like the radius. And this is like the tangent. So radius and tangents are always perpendicular. Radius is perpendicular to tangent. See, look at this. This is called as tangent basically. So this is tangent for this circle and this is the radius. PM is the radius and OM is the tangent. PM perpendicular to OM because radius is perpendicular to the tangent. Therefore, this angle is going to be 90 degrees. So, in triangle PMC, angle M is 90 degree. In triangle PMC, angle M is 90 degree. And if that angle is 90 degree, this is Pythagoras theorem. 2 square, one side square plus second side square is equals to hypotenuse square, which is 2 plus R the whole square. And once you solve this equation, you're going to get R is equals to 4 by 3 centimeter. Just solve this equation, you're going to get R is equals to 4 by 3. How are you going to solve this? 4 plus 4 minus R the whole square. 16 minus 8R plus R square, which is equals to, how are you going to solve 2 plus R the whole square? 4 plus 4R plus R square. And now this R square and R square will get cancelled. In case someone doesn't know how to do A plus B the whole square, watch my another videos, how to do A plus B the whole square, A minus B the whole square, I have already explained. So R square and R square will get cancelled. And now you can cancel this even 4 and 4. So we left with this 16, which equals to 8R plus 4R. That will become 12R. So 16 by 12, which equals to R. 4 4s are 4 3s are. So R is equals to 4 by 3, which you can write 1 whole 1 upon 3 centimeter. I hope, student, you are enjoying and you are understanding everything and your doubts are also solving. So you are liking it, and in case if you are liking it, put thumbs up, say we like it, and keep asking the new doubts so that I can keep helping you with the new difficulties. Okay, we are solving next sum as page number 437. 437. Sum number 2b. So on page number 437, sum number 2b. What is the sum? There is one semicircle given. And this is the center of the semicircle O, and this is the diameter AB, and we have got three more points here: E, D, C, and now this point have been joined like this. This is also joined with this point B, and this is also joined over here. And you join this and this and this and this. So what all things are given over here? This is 140 degree. This is given, this chord is equal to this chord. And let's read this question very carefully, one by one, slowly, gradually, and keep writing the data on the board. In the given figure below, AB is the diameter of the circle. So if AB is a diameter, AO need to be equals to OB. Next, also we can understand that in case if we'll join these or these, that makes 90 degree. That we'll see little later on. Let's see further what all things are given. A, B, C, D, in its center O. If EA is equal to ED, if AE is equals to ED, that means if the chords are equal, student understand, if the chords are equal, the arcs are also equal. If AE is equals to ED implies arc AE is equals to arc ED, implies if these arcs are equal, even the central angles or angular circumference will also going to be same. So if these arcs are equal, what we can say, ABE, therefore angle ABE is equals to angle EBD, is equals to angle EBD. Student understand, when the chords are equal, at the same time the arcs subtended by them are also equal, and if the arcs are equal, angle at the circumference will also going to be equal. Let's see somehow this is going to be helpful in further things. Angle BCD is given as 140 degree. This is given as 140 degree. And what you have to find, angle AED, 1 to find. See, most of the student, they never write it down all this given data or what you have to find or what is given. So what exactly happened? They find the math subject is very difficult. Why the maths is very difficult, they feel? Because they never write this. So always identify what you have to do. We have to find angle AED to angle EBD, angle EBD, and also you have to prove that OE is parallel to BD. We have to also prove that. Third thing, what we have to do? We have to prove OE is parallel to BD. OE is parallel to BD. We have to do these three things to prove that. Okay, so we have to first of all find what is angle AED. That means we have to find these whole angle. To angle EBD. Where is EBD? EBD. That also we have to find. These were the angle we have to find. And we have to also prove that OE is parallel to BD. Now student, how are you going to do this? This is like kind of how are you going to do this? How are you going to manage this? See, it's very simple. It's very simple, student. If this is 140 degree, look at this. This particular portion. Supposed to be 40 degree. Why is supposed to be 40 degree? See student, understand. If this is 140, this is supposed to be 40. Why? Because opposite angles of the cyclic quadrilaterals are always 180 degree. Opposite angles of the cyclic quadrilateral EDCB is a cyclic quadrilateral. So opposite angles of the cyclic quadrilateral are going to be always 180 degrees. So I'll write it down this. This is, let's say, X. So in quadrilateral EDCB, let's say this is angle X, angle DEB plus DCB, angle DCB is supposed to be 180 degree. And what is the reason for this? Opposite angles of cyclic quadrilateral add up to 180 degree. Angle DEB plus angle DCB is always 180 degree. So if this is X plus 140 is supposed to be 180 degree. So X is equals to 40 degree. So X is equals to 40 degree. So we got this X is 40 degree. And this whole angle is supposed to be 90 degree. Isn't it very simple and obvious? Why this is 90 degree? Because AB is a diameter. AB is a diameter of this semicircle. So this is supposed to be 90 degree. Angle subtended by a semicircle is always 90 degree. Isn't it simple? So we got angle AEB. Angle AEB is supposed to be 90 degree. Angle subtended by semicircle is always equals to 90 degree. And now if you add this X and angle AEB, X is angle BED, angle BED. If you add these two, what is angle BED? BED plus AEB. These two angles will go to add up to 130 degree. These two will add up to 130 degree because X plus 90 will going to be 130 degree. Now what is that angle named as? AED. Angle AED. Isn't that magic? That's our part 1. Angle AED is 130 degrees. So student, these math sounds are always very simple. The only thing is how you use your properties of the circles. Isn't that simple? So we finished first part of the sum, AED. Now what is the second part of the sum? Angle EBD. Where is angle EBD? E, B and D. This portion. How are we going to find these? See student, that is also very simple. We have to use our circle properties or these angles in circle very carefully and very nicely. So these sums will become very simple for us. See, how we will find angle ABD? See student, first of all, we found this is 130 degree, isn't it? And now, in case if you have observed, AEDB is also a cyclic quadrilateral. I'll repeat, AEDB is also a cyclic quadrilateral. So if this is 130 degree, even this will going to be add up to 180 degree, isn't it? So I'll just name the property, the angles differently, okay? And this will going to be the same everything. See, first of all, we'll have to write AEDB in quadrilateral, AEDB in quadrilateral, AEDB, angle AED plus angle DBA. DBA is supposed to be 180 degree. So we got angle AED plus angle DBA is supposed to be 180 degree because opposite angles of the cyclic quadrilaterals add up to 180 degree. We know angle AED is 130 degree. We just calculated angle AED is 130 and angle DBA we will still find. So angle DBA supposed to be 180 minus 130. 180 minus 130, which is 50 degree. And if this whole angle is supposed to say 50 degree, we know that this each part is supposed to be congruent. So 50 is half. 50 is half is 25, and that's your answer. This is 25 degree. And how am I going to write it on this? So we know that angle ABE supposed to be equals to angle EBD. We have written over here. Look at this. Angle ABE is equals to angle EBD. So this is equals to, this all is equals to angle ABD's half, which is 50 upon 2, which is 25 degree. I hope student you have understood this part of the sum also. So after this, please write down this. If AE is equals to AD, arc AE is equals to arc. If chord AE is equals to chord AD, then the arc AE is equals to arc AD. And when the arcs are equal, the angles are equal over here. Angle ABE is equals to EBD. If these two angles are equal, then this angle plus this angle going to be this full angle. So that's why I wrote angle ABD upon 2, which is 50 upon 2, which is 25 degree. So we finished the second part also. Now we got this, each is 25 and 25. Now we have to prove that these two lines are parallel. And that parallel part is also, student, very simple. See, it's very easy. If this one angle is 25 degree, look at this. If this one angle is 25, this full angle is supposed to be 25 into 2, which is 50 degrees. Why 50 degrees? Because angle at the center is double the angle at circumference. So if the angle at circumference is 25, so angle at center will going to be double the angle at circumference. Agar ye 25 to ye 50 banega. If this is 50 and this full angle is also 50, this line will go to be parallel to this line by converse of corresponding angle test. Isn't it? Why these two lines are parallel? I hope student you have understood this, why why these two lines are parallel. How? Again we'll repeat. If this is 25, the central angle is going to be 50 degree. Why this is 50 degree? Because central angle is double the angle at circumference if it is subtended by the same arc. They are subtended by the same arc AE. So if this is 50 degree, this full angle is also 50 degree, then this line and this line going to be parallel because corresponding angle test. When these two angles are equal, by corresponding angle test, these two lines are going to be parallel. So I hope you can write it in that third part. Okay, so what is the next sum? The next sum is, we'll do some more sum based on tangent properties. There is one circle and these two chords are intersecting externally, and then there is one tangent, it is touching like this. And this is T, this is P, and this is A, this is B, this is C, and this is D. And what all things are given to us? In the given figure below, AB and chord CD circumvents at P, PT is a tangent to the circle, CD is equal to 7.8 centimeter. CD is equals to 7.8 centimeter. and PD is equal to 5 centimeter. Where is PD? PD is equals to 5 centimeter. PB is equal to 4 centimeter. PB is equals to 4 centimeter. And what we have to find is, I'll just write it down. So what we have to find over here, there are two things we have to find over here. Student, make sure that this is just the last sum. So keep watching this sum and then we're going to find out. In case if you have doubts or difficulties, you can put that in the comment box or else on our WhatsApp group. So one thing is find AB and two, find the length of tangent PT. So we have to find what is PT. There are these two questions. So let's solve this. How to find this AB and how to find this PT. These are the two tasks. So we have been given CD is equal to 7.8, PD is equal to 5 centimeter, and CD is equals to, PB is equals to 4 centimeter. So student, we know that property whenever the two chords are intersecting, whenever the two chords PC and PA, these are the like two chords, they are intersecting externally. So we know that PA into PB is equal to PC into PD. We know there is nowhere AB in this property. Still we are going to use this property because the property says go to the point of intersection from there P to A into PB is equal to PC into PD. All those people who have just joined, for them I will repeat this property. Please watch the initial part of the video because in that I have already explained these properties. So in case if you have missed this initial part, please watch it once we will finish this session. Okay, so what is this? PA into PB is equal to PC into PD. And how are we going to do this? Okay, so PA into PB. Okay, we know PB. We do not know PA, so I'll copy it as it is. What is PB is? PB is 4 centimeter. What is PC? PC is this the full thing. So 7.8 plus 5, that is 12.8 centimeter. Into what is PD? PD is 5 centimeter. And now if you solve this, you will get PA. PA is equals to 12.8 into 5 upon 4. 4 3s and 2s. So PA is equals to 3.2 into 5. 10, 1 carat, 5 is a 15, 16. So PA is equals to 16 centimeters. So if PA is equal to this full length is 16, PA is 16, or that PB is 4. So how are we going to calculate AB? AB is equals to PA minus PB. So PA is 16 minus 4, which is 12 centimeters. So we got AB as 12 centimeters. I hope students you have understood this. I know I'm going a little fast because there are so many people asking so many doubts. So how are we going to do this? This is 12 and this is 16. So 16 minus 4, 12. This total is 16. This is 4. So this is 16 minus 4, which is 12 centimeter. How are you going to find this PT? So PT you can do by any which way. PT square is equal to PA into PB, or else PT square is equal to PC into PD. So how are you going to do this? PT square is equals to PA into PB by using tangent secant property. What is this tangent secant property? Tangent square is equal to PA into PB. Again, you should go to the initial point or else point of intersection. Do not start like this, AB into AP, because that is A is not the initial point. So in case if you have started with A, your sum might go wrong. So you should start with point P. So PT square is equals to PA into PB. So what is PT square? We do not know. What to calculate? PA कितना है? PA is PA. We've just calculated in the previous sum. That was 16, and PB is given as 4. So PT square will going to be 16 4 is 64. So PT will going to be root of 64, and root of 64 is 8 centimeters. So that is that easy. So simple sum, isn't it? So we make learning easy at Easy Learning Center. I hope student, if you have enjoyed this or watching this entire video, in case still you have doubts pending, put it in the comment box. Don't worry, I will shortly solve them as early as possible. And student, in case if you have not subscribed this channel, definitely subscribe it today only. It's we are about to finish this circle right now. Thank you for watching this video till the end. Thumbs up. Let's have more such session so that I can help you more in maths. Keep watching this video and enjoy maths. Thank you.